Let us look at proposition number 14 of book 4 of Euclid's Elements. The proposition says to construct a circle around a given pentagon, a regular pentagon. More precisely, it says circumscribing a circle on a given equilateral and equiangular pentagon. Let's see how we can go about doing this. This is our given pentagon. So the first thing that we do is take any two angles. So let's take BCD and CDE and bisect those angles. We know how to bisect it, so I'm not going to carry out the individual steps. And let's mark the intersection of these two lines. Now this would become the center of the proposed circle. Okay, so now let's hide these two lines and let's join F with all the points. FC, FD, FB, FA and FE. Now be clear about one thing, that FC bisects BCD is true. Why? Because we bisected it using a previous proposition. Similarly, FB bisects CDE is true because again we constructed it, we bisected this angle. But these three lines, we just join these points. So we don't know whether it actually bisects these angles or not. So first we have to prove that these lines bisect these angles. And then we have to prove that FC equal to FD equal to FE equal to FA equal to FB. So let's see. This is pretty similar to our previous proposition. We know angle FCB is equal to BCF. Why? Because CF bisects BCD. So these two angles are equal. We know CF is the common side for these two triangles. And we know since it is an equilateral pentagon, BC equal to CD. So side angle side. Based on that proposition, we can say that these two triangles are congruent. Now, if these two triangles are congruent, that means angle CBF is equal to CDF. If we look at CDE angle CDE, that is twice this. Why? Because this bisects CDE. So this blue angle is twice the black angle. But this angle is equal to this angle, which means what? Angle ABC. Since this is a regular pentagon, it means CDE is equal to ABE. And this line bisects it, so CDE is twice FDC. But CDF is equal to CBF. That means ABC is also twice FBC. So that means BF bisects ABC. Similarly, we can go around and prove that each of these angles are equal and these lines bisect these angles. Actually, this would also be equal. BCD will also be equal to CDE. Because again, this is twice this. Remember, this is a regular pentagon. So this all the angles are equal. So this angle, the total angle BCD is twice this angle. This angle is twice this. Since these two overall angles are equal, that means individual angles are also equal. So we have proved that angle FCD is equal to FDC. So which means what? FC is equal to FD. Sides opposite to equal angles. Similarly, we can prove that BF is equal to CF, FD equal to FE, FE equal to AF. So that means all these line segments are equal to each other. So that means if we draw a circle with center F and radius any one of them, we will get a circle which touches or goes through all these points. So basically, this is what we are proving. And as you can see that the circle passes through all these points. Now, this, I don't know, the circle may look a little bit wonky. That is only because of these points. They somehow seem to bend the circle a little bit, but it is actually a perfect circle. It's more of a illusion. So we have circumscribed a circle around a equilateral and equiangular pentagon. So that was proposition number 14 of book 4 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.